I want to take a look at two topics here, area of a triangle and the law of sines. We should note that the area of a triangle is 1/2 base times height. But what if we don't exactly know what that height is? Maybe we have all the other measurements for it, but we don't know what that height is. One thing that we can do is that when we draw in the height of this triangle, we've created a right triangle, which I'm going to pull out over here. In this right triangle, we have our angle A on this side. B is not this entire base. Remember that B goes all the way across from A to C. So we really don't know what just that portion is. I know what the height is, and I know that the hypotenuse of this triangle is going to be C. So if I have an angle, its opposite side in the hypotenuse, that sure sounds like sine to me, that the sine of A is going to be H over C. Then to solve this equation, I would just multiply both sides by C, and H is C times the sine of H. Now, all we did was come up with an expression for H. Going back to our formula for area now, we could rewrite area, instead of being 1/2 base times height, it could be 1/2 times base, the entire base of the triangle, times the height, which we just saw is C sine of A. So we've created a new formula that will also find the area of a triangle when we don't know what the height is. So 1/2 times the base, and then the sine of the angle times this side right next to it. So let's find the area of this triangle where A is 31 degrees, B is 18, and C is 22. A good first step is to draw the triangle. And I'm going to start by drawing a 30-degree angle, a 31-degree angle, which looks approximately like that. That's my angle A. And then side B, if I put that on my base, is 18. And then side C is going to be longer than that 18. It's going to be out here, 22. C is 22. Then we can connect those two sides to get the other side of the triangle, where we would call side A. This would be vertex C and B. So if we want to find the area of this triangle, we can use that same formula where area is going to be 1/2 times the base of the triangle times the hypotenuse. Well, this isn't technically a hypotenuse since it's not in a right triangle, but this side, 22, times the sine of 31 degrees. We can do a little bit of simplifying, like 1/2 of 18 is 9, and 9 times 22 is 198. Something that you could do in your head, but finding the sine of 31, probably not something you're going to do in your head. So when you grab your calculator, first of all, make sure that you're in degree mode, but then go ahead and type in 198 times sine of 31, and what you should get is 101.977. And remember, that's not the side length or anything like that. That is the area of the entire triangle. The second topic that I want to look at is what's called the law of sines. And there's a special relationship that happens in any triangle that compares the angle with its opposite side. And this ratio is going to hold true, that the sine of angle A is related to side A in the exact same way that angle B and side B are related, so that's the same as the sine of B over B. And that's the same as the relationship between angle C and side C, that the sine of angle C over C. This ratio is the same no matter which pair you're talking about. Its angle and its opposite side. Now, where the law of sines comes from, it can be proved through using area. For instance, here I have a triangle. And what I'm going to do is take that same triangle and look at it in three different ways. I'm going to look at it as A being in that bottom left-hand corner, or spinning this around, having B in this bottom left-hand corner, or having C over here. Kind of got, here we go. So that the three triangles still had the same area, but we're just looking at them in different orientations. And when we think about that area, remember, it's 1/2 times the base of the triangle times this side sine of that angle. Okay. And when we look at the same triangle but oriented different, where we're focusing on angle B, then this area is 1/2 times the base A times C sine of B. And when we get to the third triangle, where we're focusing our attention on angle C, that area would be 1/2 the base B times A sine of C. And no matter what way we look at this area, all those areas are the same. So all three of these expressions are the same. And we can set up this kind of three-sided equation. And what I'm going to do on all three sides is I'm going to multiply by 2 first. So then I would have BC sine of A is equal to AC sine of B is equal to AB sine of C. Then I'm going to divide all three expressions by ABC. And we'll see the canceling that happens, resulting in the ratio sine A over A. Over here, A and C will cancel, so we'll be left with sine of B over B. And in the third one, A and B will cancel, and we'll be left with sine of C over C, which is the law of sines. Now, how are we going to use the law of sines in order to solve a triangle? Of course, what we mean by solving a triangle is to find the measurement of all three angles and all three sides. And when we look at the diagram that we're given, we can see that we have a lot of those measurements already. First of all, we have 2 of the 3 angles. I see that angle C is 80 degrees and angle B is 45 degrees. We also have this side that's 3. Since it's opposite of angle C, that's side C, and its value is 3. So it looks like we only have to really calculate 3 other measurements. So I'm going to take them one at a time. First, I'm going to take the angle. Since we know all 3 angles have to add up to 180 degrees, that would mean that A plus angle B, 45, plus angle C, 80, would have to equal 180 degrees. So if I were to subtract 125, which is the sum of those two, from both sides, we see that A is 55. So A is 55 degrees. Now for the 2 missing side lengths. In order to do that, I'm going to use the law of sines, and I recognize that I have this pair, this angle and its opposite side. That's half of the law of sines that we need, because the sine of 80 degrees is going to be related to 3 in the same way that the sine of B is related to B. Well, angle B is 45 degrees, and it's side B that we don't know. And when I'm looking at this equation, I got one fraction is equal to another fraction. This is a proportion, and we solve them by cross multiplying. So B times the sine of 80 is just B sine of 80. And over here we'll have 3 times the sine of 45. To finish this off and get B all alone, we have to divide both sides by the sine of 80 degrees. Now be careful when you're typing these things in. Make sure that you have an open parentheses, you close the parentheses, make sure you got your fractions all right. It may be better to take it in two pieces and do sine of 45, enter, times 3, enter, divided by 80. But if you do it correctly, you should get your calculator say 2.154045129. Of course, this decimal continues to go on forever and ever. We don't want all of it. As far as what I'm going to want you to do is to go 3 decimal places. You can either round or just cut it off as 2.154. And now for the third side of the triangle, we can't use Pythagorean theorem or anything like that because we don't have a right triangle. We have to go back to using the law of sines. And I now have 2 pairs. I got angle C and side C along with angle B and side B. I'm going to use the one that's more accurate and also nicer numbers, and that is C. So the sine of 80 degrees over 3 again. And so the sine of C is related to C in the same way that the sine of A is related to A. And again, we have this proportion, so again, we're going to cross multiply in order to solve it. And so A sine of 80 is equal to 3 sine of 55 degrees. And this is starting to look pretty familiar to the last one. Don't think that, oh, just because the angle is 10 degrees bigger that something magical happens mathematically. It doesn't. We still have to go through the same process of dividing both sides by that sine of 80 degrees. Gets those 2 to cancel. And so we have 3 times the sine of 55 divided by the sine of 80, and we get 2.4953. And of course, we only want to go 3 decimal places, 2.495. Before you leave a problem, of course, you should check to see if your answer makes sense. And how you will know it makes sense is by comparing the angle to the side. The biggest angle, 80 degrees, should be paired with the biggest side, 3. And the smallest angle, 45, should be paired with the smallest side, 2.154. Once we have all that, it seems pretty reasonable that we got good answers. Let's go through this again. A new triangle, RST. If we're going to solve the triangle, we need to identify all the angles and all the side lengths. So some of them we already have. We already have that angle R is 105 degrees. Side R is 9. Side S is 6. That's all we have. So let's go to starting to find some other lengths. Now, because we only have one angle measure, we can't start subtracting from 180. But I do have this pair of angle R and side R. So I'm going to set up the law of sines, that the sine of 105 degrees is related to 9 in the same way that the sine of angle S is related to side S, 6. And we have this proportion that we need to solve. So we cross multiply. 6 sine of 105 is equal to 9 sine of S. So we'll divide both sides by 9. You could simplify if you want. 2/3 times the sine of 105. And how we're going to get rid of this sine is by using the inverse sine. So it might be a good idea to pause right now and find out what that decimal is. That 2 sine of 105 divided by 3 is 0.6439. Now remember, that's not S, that's the sine of S. To find out what S is, we're going to have to take the inverse sine of 0.6439. And of course, it's better to use the answer key on your calculator to get all of the decimals instead of just 4 of them. And we will get this angle to be about equal to 40.087. So that means that angle S is 40.087 degrees. Now that we have two angles, to find the third one, we would just subtract 105 and that 40.087 degrees from 180, and we'll end up with the third angle being 34.912, or rounding 913 degrees. To find the third side, we can't use Pythagorean theorem because it's not a right triangle. Instead, we have to use law of sines. So the sine of 105 is to 9, in the same way that the sine of that 34.913 degrees is to side t. All right, not ideal to be using a number that's rounded off so much, but that's why we'll go 3 decimal places to cut down on that round off error. Solving this, we're going to cross multiply. And then divide both sides by that sine of 105 degrees. When you do that, you should get that t is equal to 5.332. Finally, to check our answer, we kind of look back and we see that our largest angle is paired with our largest side, and our smallest angle is paired with our smallest side. So it looks like this is the solution to our triangle. This last one, this is one of the word problems out of the book, actually one from the homework assignment today. That this picture is of a few craters on Mars, and we've got a few measurements here, and we want to find out how far it is from this Wahoo crater over to Naucan. How long is this side, basically? In order to do that, we see that we're given this angle 23 degrees and the length of its opposite side. So we can use our law of sines, which is related to 1.2 kilometers, in the same way that the sine of 102 degrees is related to that distance we don't know, x. Once it's set up, the problem is a lot like the last couple, where we have to cross multiply. X times the sine of 23 is equal to 1.2 sine of 102 degrees. Divide both sides by the sine of 23. And we get an answer of x equals 3.004. Now, of course, remember this is a word problem. In word problems, numbers aren't numbers, they're measurements. That this 3.004 is actually 3.004 kilometers.